Hey everyone, welcome to 2025, and today we're going to be looking at errors, and specifically we're going to be looking at exceptions within Object Pascal. And if you ever run into a situation where you get an error such as there was an unhandled exception occurred at an address, well, what caused that? How do we fix it? Where did it occur? So we're going to look at what exceptions are, how they work, and how that we can make our code a little bit more user-friendly, robust, etc. So the first question we need to ask ourselves then really is, what is an exception? And in simple terms, an exception is an event which disrupts the normal flow of our program. And you can think of it as something unexpected happening in your program, like you could get it when you try to open a file. You could get it when you're trying to connect to a database. You could get it when you were trying to run an SQL query. And let's say there was an error in the SQL statement. Well, when you run it, that can generate an exception also. So in the case of this particular message here, this is the program here that did that. And I think I showed something like this in a short a while ago. And well, how can we make it, let's say, more robust, to go back? So what we're going to do here is well, actually what I should say first of all here is, because this line here generates an exception, and we are in the main program here, the default exception handler that gets bundled in, shall we say, will trap the exception, do something, and then the program will terminate. So if we were to move these two lines of code here down into here, we will see what happens next. So the idea being is that we're going to run this bit of code here. Assuming that's successful, it will do that. If this is unsuccessful, it jumps down into the exception block. Actually, we need to get rid of that line. Into here, do whatever that does, and because an except block will contain the error or localize the exception, the program will then continue after the after the except block. So here now you can see that an unexpected error occurred. That's this line here. I might make that a little bit bigger actually, so there you go. And I'll definitely, and I hope you can see this one. So yeah, so basically you got that line there being output, that line here generated the exception. It does that and goes down to here. An exception by itself is similar to the, let's say, a C++ catch-all type exception. Now you can, if you want to, because exceptions exist in a hierarchy, if you want to capture a specific type of exception, we can do that as well. So what we'll do here is we're just going to copy that one and move to there, and this time here we're going to say div by 0. And actually, just to show what I did there, basically I hit the Control and spacebar, and it shows me all the possibilities of what I can use as far as an exception might be concerned, and well, a bit more than that. So if we get a division by 0 error, this will be output. If it's not that error, then this exception handler will come into play. So let us rebuild the program again, and this time you can see rather than getting the unexpected error, we now get a div by 0 error occurred, and we got the program end line. Now this is one way of dealing with an exception in Object Pascal. The other way is with a try finally block. Now I'm not going to actually run this one, but if you're working with a file, shall we say, well actually, if you're working with a file, so I will actually put this back to how it was, ex. So normally you'll, let's say, open a file, write to file, close file. Now, suppose an exception occurred when you tried to write to the file. At some point in time, well actually, and let's suppose also that even if the write were successful, you still want to be able to close the file. So this is where the finally bit comes in. Regardless of whether this failed or not, or successful, this bit of code here is guaranteed to be executed. It also does not, local or contain the exception. It will actually go back to the caller, to deal with as well. So if you were doing something like, trying to deal with a file, or even a list where you may get a range error and you wanted to free the list before, continuing on. Again, it's for making sure that you manage your, let's say, resources carefully so you don't get a leak. That's one reason why you might do that. So that's the other way. You'll also see from this example here that we can also, deal with multiple exceptions within the one exception block. So it's not like you can only deal with one type. You can deal with many. The next thing you might want to be aware of then is, well, what if I am in an exception, but I just want to log something that happened, an unexpected, an error occurred, but you also want the caller to be aware of an exception and know what the exception was and deal with it accordingly. So in this case here, what you would do is what they call re-raising the exception. And to re-raise the exception means just calling, at the end of your own code in the exception block, you would call raise, and that will then propagate the error up in the call stack or to the caller, and it can deal with that error itself. In this particular case here, if I were to put a raise here, well actually let's just show what's going to happen. Raise, and I want, let's go to, I'm going to put in here, just so you can see where mine stops and the other one starts. So this was where I captured the error, and because I re-raised the error, the application's exception handler kicks in, and I get all of that information there being output. So you can see where I ended and it did something itself. Also in this particular case here, because it goes to the caller, this line here doesn't get output as per the previous examples, where because the error was localized, the next statement can then be executed. Then we'll look at now what I would refer to as custom exceptions. So where might you use a custom exception? Well, imagine you're writing a component or set of components. You could be writing a network library, you could be writing a reporting engine, you could be writing a graphics tool even. So, and in this case here, you would want to be able to raise your own exceptions. And something like Indy would have its own class of exceptions. And in this case here, what you can do is, let's go up to here, you could do, and why don't we just put in here a, so in this particular case, we've defined our own exception, and when we raise the exception, we specify the message as well. Whoops. And so when the error occurred, it gave us the message here, and because we're re-raising it, then that's why we got the rest of it. But the other thing to note here is, with the debugging turned on, or being enabled, we can also see the get the call stack. So something else to think about, specifically when you are doing debugging. Now the other thing which I wanted to point out is here that you can also, because let's just go into, we're going to look at what's in an exception right now. Let's see what that one brings out. The class name. So if you did the exception to string, you would get the class name as well. So if we go back to here and we changed this, let's just now you can see it also output the type of exception that occurred before the message itself. So you can actually, because the exception itself exists within the object Pascal hierarchy, it's able to utilize other features of the language. So again, we're going to look at some, let's say, some common areas where exceptions can occur. So files, you can't, permission denied or file not found. A one location, you'll typically, let's say with, you may use it with get them with input validation, where an incorrectly formatted email address, for instance, or a incorrectly formatted URL, or incorrectly formatted phone number. Another place you can get them is with in network libraries, again, where you have a connection failure or a timeout. Database operations, where you can have a query failing or, again, a database connection issue. I would say also, though, that if we do look at this example here, we don't want to use exception handling as our default mechanism to capture all errors. If you can capture the error beforehand, do so. Use exceptions for exceptional conditions again. So that I can wrap that probably up. I could wrap that up into this statement here. We use exceptions for exceptional conditions, not to for regular, routine control flow. Try and be specific as possible, rather than just using a, while I am using a toString here. Don't just have try, except, exception, got a problem. Try to, be specific. The other thing then is that what you don't want to do is something like that which is referred to as swallowing up an exception. Essentially, all you're doing is hiding the exception, which doesn't help anyone. The try finally block then allows you to clean up after something goes wrong. So that's about it for this video. Exceptions are, like I said, used in Object Pascal. We need to know how to use them, or and understand what they do. And they can help keep your program running smoothly even when something goes wrong. So I'd love to hear your thoughts and experiences in this area. How do you use them in your own projects? And don't forget to like and subscribe, and to click that notification bell, ding ding, so you don't miss an update. And thanks for watching, and I'll see you in the next video. Bye.